final project, we implemented a device that is able to recognize what note that we're playing out of the recorder, and then it maps it to different keyboard and mouse inputs. So with this, we are able to play games like Minecraft. So for example, if I go ahead and set this up, then I can play. If I want to get out of the water, I can do. Playing the recorder is still kind of hard for me though.
Which one are you playing?
And this is a tree that I took a little chunk out of earlier. So if we get close to it. Getting actual chunks out of the block is a little bit tricky, but yeah,
a big breath of air.
Yeah. But for example, we can look left and right. Yeah. There we go. If I want to go put that block somewhere else, then I can go ahead and turn around.
We can only move at one speed. Do you want me to take over?
Oops. Oh, really? Did I do that? Okay. Damn, now I gotta scroll back.
So you're scrolling the menu.
Yeah. He needs to get some food. There we go.
Because the scrolling is also just continuous.
Yeah. All right. I'm gonna call that the end of the demo.
Perfect. Okay. So how does this work?
So we're using code that's pretty similar to our FFT code from Lab 1 to recognize the notes. We basically just we separate all of the frequencies into bins, and we say whichever is the closest frequency is the note that we're playing. Then we have 4 threads running, two on each core. So we have a thread for the FFT to determine the frequency. We have a thread for the VGA display to display the frequencies on here for debugging. We have a thread for the USB stuff for tiny USB, and then we have another thread for serial output. So the serial output is useful if we don't want to plug into the display, but we still need to like tune the recorder and make sure everything's working correctly. And then the USB thread works by sending a series of reports where each report is like information about the current state of the keyboard and mouse. So every time it sends a report every 10 milliseconds, and every time that it's time to send a report, it chooses what type of report to send based on what note is currently being recognized.
Okay.
So for example, if it's C in octave 5, then it will send a report that says the W key on the keyboard is currently pressed and none of the buttons on the mouse are pressed.
Okay.
And yeah, that's pretty much it.
And then, so what was this piece of paper that you were referring to as you were playing?
You just make fingerings.
Yeah,
Oh,
the
okay.
commands we
This
wrote
is
down.
this is the fingering chart that came with the recorder, and I wrote the key bindings on it to help me remember.
Okay.
Playing that was apparently a hard part of the project as well.
Yeah.
Very, very cool.
So this is working through tiny USB.
Yes.
How was that to get working?
So tiny USB was like non-linear progress. So at first, we took an example of the Raspberry Pi GitHub and dropped it into our code. to be able to like get the basic keyboard stuff working, and that was pretty straightforward. But then when we tried to integrate it with the notes, we couldn't get it to do mouse movements related to the notes. We only got it to do keyboard movements related to the notes. And that was because we were passing in the note as like a parameter to the tiny USB function, but the function works in a weird way where the keyboard reports are delivered separately from the mouse reports in two separate function calls. So only the first one was getting the note information.
Okay.
So then we solved that by just making it a global variable.
It's hilarious. Really, really well done. Thank you
Thank you.
guys.